Hi, my name is Leonardo Facchinetti, and let's write some code together, shall we? What we have on the menu today is the preliminaries of what is going to become a compressor. A compressor is one of the effects that I want to do for real. I mean, it will be a bigger effect with more visualization, lots of parameters, lots of controls, and lots of stuff happening. But we are going to start with the very, very basics. In fact, I have never written a compressor before. Let's try it out and see if we can make it happen. Wish us luck. So what we have so far is, for a bit of context, we are developing this library that is going to help you develop, I keep saying develop, that is going to help you write real-time audio processing effects for REAPER. And we have in our library some things that will be useful for the compressor. Namely, we have a way to compute RMS, and we have a way to show RMS over time. Now, it's not 100% there, but we did develop last time. It was on Friday. We developed this component that draws a line graph. And in that example that we did on Friday, it was drawing the waveform over time. But we can also ask it to draw the RMS values computed over time. So actually, I think I'm going to start this compressor idea kind of backwards. I'm going to start with the visualization, and then I'm going to try to do the audio portion of it. Why? Well, first, because I don't know a lot about how a compressor works internally. Well, I read a lot about it, but I have never implemented it. But also because I think that the thing that is missing in the market is good visualization on the free and open source world. Now, there are many free or donationware compressors, and they sound great. Many people say that they love it, and some of them even have some sort of visualization of what's going on in the compression. But I find that things like Pro C2 help you see compression. It's so beautiful. It helps you understand what's going on, and it helps you dial in the parameters very well. So the thing that we are going to do is going to be visual. In fact, I'm going to start with the visuals. So I think that the first thing I want to do is to draw a waveform, and then I'm going to draw the RMS. There are different ways of doing compressors, one of which is to look at the RMS. I'm going to look at RMS to begin with anyway, because we already have a component to do that. So what I want is to just draw the waveform, draw the RMS over time, and I'm going to do just the slightest bit of I'm going to have some threshold, I'm going to have some gain reduction. It is actually going to compress the waveform, hopefully, and we'll be able to test that. So GSPT4760 says, hey GSPT4760, great to have you here. And Bo says, hey Leandro, and hey guys, Aria, yes, that's what's happened. So I usually stream at 6:30 on my time zone. And now that means 6:30 UTC. But don't quote me on this. I'm terrible with time zones. I freaking hate time zones. In any case, yes, that's why the stream is a bit later. And Aria, if you're watching this, yes, I did check your email. So for all you who don't know what Aria is talking about, Aria won't be able to make it tomorrow on his channel on our usual Tuesday stream about coding. We are going to do the Wednesday stream about audio production over here on my channel. And we may or may not do the stream about coding on his channel on Thursday. So that's what's up. Right, let's get started with this. It's a grandiose view. I want to build something like Pro C2, or at least that's the starting point. We may want to make different decisions, and it will end up looking completely different. But I'm going to start with the visualization for a compressor. And I don't think it belongs here in this demonstration thing. So to catch you up in case you missed this, I'm developing this library, and then I'm developing this effect that is supposed to showcase what the library can do. That's not, what we are doing today is not going to go into this. We are going to start a LIAFAC compressor. And people tend to give compressors, or people tend to give effects novel names like C2 or what is another good compressor, L2A2 or whatever. I'm going to call this the compressor, because if you're looking for a compressor in Reaper, you just say compressor and my compressor is going to show up. So it's going to be Liafac compressor, Liafac gauge, Liafac limiter, and so forth. Yes, I'm planning on doing all these kinds of dynamics effects. And my view is that it is going to be visual, it is going to look nice, it's going to help you pick the right parameters, everything is going to be calibrated well. So I want to be your go-to compressor. I'm not necessarily interested in making things sound I'm not interested in saturation right now. I'm not interested in character. I'm interested in doing a clean compressor, utilitarian, nice looking, your go-to compressor when you don't want to think about it. That's the view. It's going to be a long road until we get there, but that's the view. So first of all, I'm going to something that I always neglect in all my effects, I'm going to give this a name so that in Reaper it doesn't show up like all my other stuff. So all my other effects just show up with the file name. This one is going to show up with a proper name. In fact, it's already here. It's a compressor. So there you go. I put it on the track. Then I'm going to import the library. And then let's do some stuff for initialization. First of all, we are going to initialize the library itself. Then we are going to compute the RMS. So I'm going to start an RMS computation here. And we are going to need a circular buffer to store the samples as they come in. So we are able to draw the waveform. And we are going to need this. We are going to need to store the RMS over time. So we need a circular buffer for RMS as well. And when I'm creating RMS, if I remember correctly, I have to give it the window size. So for now, let's just pick a window size of 300 milliseconds. It is like a value that I think it's the value 300 milliseconds is the value that is used for momentary computation of loudness in LUFS. So that's why I'm going with 300. And also the tri-leveler by Sonic Anomaly also uses an intermediary RMS thing, which is not too fast and not too slow. And it is at 300 milliseconds. And if we want it to be 300 milliseconds, this window size is supposed to be in samples, but we have an auxiliary function that is going to transform from samples to milliseconds. And we want to give it 300, well, not from samples to milliseconds, the other way around, from milliseconds to samples, right? We want to have 300 milliseconds worth of a window. Of course, we will have to parameterize this. There will be a slider for this later. We'll get there. And then we need to store the samples. So typically, I would do this for multiple channels, but I'm going to start simple and I'm going to do this mono. We are only going to work with the left-hand side. Then we will write the loops to make this multi-channel. In fact, all effects that we build, hopefully, will be multi-channel, if we can pull this off. And we are doing the library in such a way that doing multi-channel is going to be natural. It's going to be the thing that you do. So that's another thing that I don't know about compressors. I suppose that most free compressors, most VSTs, and maybe even the paid ones are stereo only, while ours can be multi-channel if you want it to be. So there you have it. So I'll call this the samples, and this is going to be a circular buffer. And I think I am going to use, for a circular buffer, I think that I need to pass the size of the circular buffer. Yes, the size of the circular buffer, and I think it needs to be the same size. So how about we just extract this into a variable that we'll call like the window size. Oh, you know what? No. I want the window size of the RMS to be 300 milliseconds, but I want my display to show more. So maybe let's say that it's going to show 2 seconds. And the same for RMSs over time. So this is the thing that computes RMS, but we also need to display RMS over time. So I'll call this the RMS sys. Terrible name, I know. Whatever. I'm also going to store this for 2 seconds so that it can have a display of 2 seconds. Then for every sample that comes in, I am going to push the samples into the RMS computation. So what is the function called again? Push. So I'm going to push into RMS the sample from the left-hand side. Then I am going to push into the samples circular buffer. So this is a circular buffer push of the sample. And the same for RMS. So I'll push into the RMSs. So I guess maybe I'll do it like this. So we store the samples first, then we push into the RMS computer, this guy, and then we get from the RMS computer and push into the RMS rememberer. So this is going to be RMS get of RMS, and you give it the computer, and it gives you back a computation, one instance of this. So this is not going to affect the sound in any way. It's just going to remember the sound that came through. But we have to visualize this some way. So I'm going to create a window of like maybe 600 by 300. And I am going to set the color to something like just white, pure white. In our library, one of the things that will distinguish our library from everyone else is the fact that it comes with a design system. So it comes with default colors, default choices for colors, for sizes, for spacing. I haven't ported this over. The library has been revamped recently, so I still don't have that. So I'm just going to set this to pure white over pure black, which is the default in JS Effects. So now I can use my little function that is going to draw some line. And I'm going to start by drawing the samples, which is a circular buffer. And this expects the data to be a circular buffer. And then for the X and Y, I'm going to plot this at 10 and 10. And for the width, I went with 600. So if I leave 10 on each side, it gives me 580 and 280 for height. And GSPT4760 says, Leandro, just a random question. I'll give you a random answer. I saw your video on Racket on the other day, and I started thinking about Lisps a lot. What would you think of a Lisp version of EEL2? Lisp JS Effects. Well, when we talk about Lisp, I will give you a random answer. Rooftop. That's a random answer. Okay, so the thing about Lisp is that there are several things that you could think about when you're talking about Lisp. The first is probably the thing that everyone notices when they look at the language the first time, which is the syntax. So if you are talking about some syntactical version of JS Effects, so that, for instance, instead of writing things like this, you would write it more like that. That is an S expression. It looks more like the kind of thing, I guess I forgot to put the underscore dot. So this is kind of the syntactical version of this line, but it has a more Lisp-like flavor because it is an S expression. So if that's what you mean, then absolutely, it's something that you can do, and it's relatively straightforward to do because Lisp has been designed to be, the S expressions have been designed to be easy to parse using something called a recursive descent parser. In other words, it's relatively straightforward to do this kind of thing. Now, if you go a little bit deeper, it gets a lot more interesting. As someone who has spent 6 years in programming language theory research, I find that syntax is super absolutely important in terms of ergonomics and usability and even marketing. You want your language to be familiar to the crowd that is probably going to be interested in using the language. So if you are in academia and you are working with like particular fields like the one that I was in, which was program analysis, static program analysis of higher order languages, then if you are playing for that crowd, then using S expressions may be advantageous. But if you are doing something that is supposed to be for everyone, then you going with something more JavaScript-like is going to be better. And JS effects are more JavaScript-like than they are Lisp-like in the syntax. So syntax, absolutely important, and many researchers would downplay the importance of syntax. I disagree. I think that syntax is absolutely crucial to market the language, to make it familiar, to help you express the ideas that you want to express in the language. But let's get deeper, because Lisp is not only its syntax. In fact, some would say that the syntax is inconsequential. The most important part of Lisp is the behavior, the core behavior. So the core behavior of Lisp, according to me, is that it is garbage collected, so you don't have to worry about memory allocation and memory safety, and that's not something that you can easily do in JS effects because of the real-time nature of audio processing. You don't want a garbage collector stopping the world to collect garbage in the middle, and then you're gonna hear a click. And in terms of the constructs and abstractions in the language, Lisp, it has high-order functions, and JSFX does not have that. Now, can you encode high-order functions? Absolutely, but it's a global transformation, so it's kind of heavy-handed. There is this process called D-Functionalization that will get you there. You can transform a higher-order program into a first-order program. And what I mean by this is just that functions in JSFX are not values. You cannot pass this function as an argument to another function. But in Lisp, you can do that, and that is a core tenet of what the Lisp language is supposed to be like when you are writing Lisp that is idiomatic. So there are many things that don't quite fit. You would have to do a lot of full program transformations to pull it off. And it is possible, absolutely. But in the end, I don't think it's worth it because, coming back to the issue of playing to the right crowd, JSFX is to do real-time processing of audio. Most people who are in that space have a background in C and C++, and then something Lisp-like is not going to fly. So if you invite me to do the Lisp version of EL2, I would say, sounds great, I would love to help you out, but I would probably not take that project myself. Okay, so that's my not so random answer. I hope it satisfies your curiosity. Right, okay, so we are plotting the samples over time on this little square. Let's see if this much is working. So I think what I'm gonna do is just maybe definitely mute and turn all of this off. I don't want to hear any of this. Just want to make absolutely sure that I will not hear anything and that you all will not hear anything. But let's start recording on the microphone that is my voice. And naturally, we need to reload this effect for the changes to happen. So now we see something. I can see my voice coming through. And that's in fact where we left off on Friday. So this much works. Now let's try to plot the RMS on top of this. So we are already putting stuff in the RMS's array. So instead of giving it the samples, I am just going to give it the RMS's. And everything else is going to be the same, but I'm going to set this to red so we can see it. So RGB, there we go. Edit, full compile reset, put it on the side, and I can see the variation. It's very slight. So the RMS here is being computed in if I remember correctly, we are outputting the RMS in terms of amplitude. Am I right? How do we check that? RMS, get. Yes, we are just getting this in terms of amplitude. I think that we should transform this to some logarithmic format. So let's transform this to dB. Or you know what? I mean, this is in fact correct, and you can see it bouncing just the slightest. So it is correct. So I could do some dB transformation and then have a better scale to show this. But I think what I'm going to do instead is just a quick hack. I'm just going to increase the amplitude of this wave so we can see it bouncing a little bit more. So maybe if I multiply this by 10, then we can get something that shows up a little more nicely on the screen. So let's see. Can come here and do a full compile reset. So yeah, it is showing more of what the gain structure looks like here in terms of RMS. It looks nice, great. But we are not doing anything to the audio. So let's do something to the audio based on this. And already this, I like this. This visualization is already better than most of the, what are they called? Most of the compressors that you see out there. I mean, most of them are just knobs that you tweak or maybe a gain reduction kind of slider. But this is nice. And 300 milliseconds is for sure a lot just by looking at the waveform. So this is not something that you would put on like drums, I don't think. But it may be something that you put on on voice or singing. And I think that the ratio would need to be very small for this to make sense. Otherwise, I think it would be like over compressed and it would pump because we can see that the RMS takes some time to recover. Right, great. Very happy that we were able to do all of this using our library so quickly. Sounds great. In fact, I'm going to commit this because I'm so happy with it. And there's still this glitch here. But I'm not going to worry about it right now. And oh, there is something else that is interesting. It's occupying a weird space on the screen. I thought it was supposed to be a lot bigger. Oh, I know what this is. We need to multiply all these values by... So the problem is that I have a retina display, okay? And I need to multiply all these values by 2 so that they show up in the right size on my screen. I'm going to multiply them by GFX. I forget. What do I need to multiply by again? I probably could go to the library instead of coming here. Okay, that's what I need to multiply by. All of these issues will go away once we have the design system in the library, because then you would not be picking arbitrary values like this. You would be picking spacing, and the spacing would be multiplied by GFX retina already. All right, so let's see what this looks like right now by editing and full compile reset. So yeah, this is nicer, occupies the whole screen. In fact, I think it could touch the edges. I don't see a point in avoiding the edges. I'm gonna go from 0. Yeah, so it's kind of silly to multiply 0 by X retina, so I'm not gonna do it. Whatever, this is just for show right now. I'm not probably gonna use most of this code anyway. But I want the thing that is for show to actually look okay. Let's edit, full compile reset. And with that, we can barely see the glitch on the right, so this is looking nice. Great. GSPT4760 says, thanks for that. I was thinking more about syntax than the Lisp philosophy, but I can agree with your points. Also rooftop. Yeah. All right. So I say all of this, not because I was smart enough to think this in the first place, but because I actually made something like that. not in not in the audio processing space, but I had this package that was to convert. It was a language that would produce CSS, but it was S expression based. And this was back in the day when I was a programming language researcher. So you can see, if you know CSS, then this is going to sound familiar. But these are S expressions. So the beauty of this is that if the world was constructed around S expressions from the beginning and no one deviated from the path of light, then you could think about expressing a whole website just using S expressions, because there is this thing called X expressions, not as X express. This is probably some porn website somewhere. X expression. I think that typically people write it this way, so come on. There, I think. Can I find an example of this somewhere, please? Come on. No, okay, that's more like it. So you can express HTML using S expressions, using this X expression thing. And then I developed this, which allowed you to express CSS. And there was this other project, I think it was called Whale Song, but I think it died. But that allowed you to compile Racket into JavaScript. So you could do HTML, JavaScript, and now with my library CSS, all using S expressions, a single language to rule them all. Great, brilliant. But the problem is, very few people know about S expressions. So of course my library didn't get any traction. If you watched my video about Racket, I think I mentioned something along those lines. And then the lesson that I took from this experience is that it's great that you can do S expressions everywhere and that Lisp can represent so much. And there are advantages to using this Lisp style. I mean, I can cite objective advantages to writing things in this style. But the problem is culture. People don't typically do that. So you want your things to play along with everyone else's things. Right, okay. Enough of that. Let's actually affect the audio, shall we? Oh, look at this, man. Just one page of code and it looks already like $1 million. Very happy. Right, so let's affect the sample. Thinking what I'm gonna do is, what do I want to do with this? Well, I want to compress. So the higher the RMS, the higher the gain reduction. So we need to introduce this idea of gain reduction. Right, let's do that. I will do this in the slider block, though I don't think I will have a slider for this just now. Right now, I think I'm going to just hard code this to begin with. So we are averaging here on my voice around like -18, I would say, -20, -18, -20, around that space. So I'm gonna call the threshold. There is a library function to convert from amplitude to dB. Well, I want to do it the other way around, from dB to amplitude. So my threshold in amplitude is going to be -20. Yeah, right. Or how about we just do some very drastic compression and let's go to -36. And I will do a very aggressive ratio so we can see the thing going down. And because we are using RMS, I think it will be relatively smooth, but I don't know. We are reaching the edges of my knowledge about compressors here. And we are reaching it very fast. GSPT4760 says there is also Racket script and Closure script. So we have HTML, CSS, and JS in S expressions. True. Racket script, I think it is different from Whalesong, and I think it's more modern, and I think that is still actively being worked on. Closure script is definitely something that exists and more people know about, but I don't know how popular it actually is. And then I wonder what the answer for CSS is in those spaces. I know that JavaScript is covered, and for HTML, I think that SX expressions are a popular answer, but in the ClojureScript world, is there something equivalent to CSS expressions? And in the Racket world, did someone pick up the mantle from my library and did something with it? I don't think so. I think it was abandoned, but who knows? All right, so threshold. What we want to do is then on the sample to compute, I'm going to call this the current RMS. Or maybe the sample RMS. That's better. And to, well, that's not actually equal to pushing. That is equal to that. There you go. And then maybe I will use the namespacing kind of thing over here as well. I'm trying to establish a convention here. Right, so this is the sample RMS. Now let's compute the gain reduction for that sample. It is going to be, well, we also need a ratio, right? So let's do a ratio of like 20. So it's almost like a limiter at this point. And the gain reduction is going to be so I think I want to do one of those knees that is just, oh, I think I have an example of what I mean here. Compressor. So yeah, this guy. I want a hard knee, and the threshold is going to be like minus 30, I think. We said minus 30 over there. Or 36? Yes, minus 36. Minus 36. And we currently don't have any notion of attack or release. And the RMS right now is, oh, there is a way to sync? How does that work? I don't think that applies here. Oh, it's just a calculator. It applies the number. So right now my project is 120 BPM by default. That's what Reaper comes with. So 1/4 of that is 500 milliseconds. And then it just computes 500 milliseconds. That's cool. I didn't know that was a thing. But in any case, we have 300 milliseconds worth of RMS. Oh, that's not possible in this compressor. Is it possible in Recomp? Yes. So 300 milliseconds, no pre-compression, no attack, no release, a ratio of 20. No knee size, which is supposed to be a hard knee. And a threshold of minus 36. All right, so whatever gain, this is, because there is another compressor in the chain. Right, so if I put this here, then we should be seeing some gain reduction here, and I expect that whatever gain reduction this is applying is similar to what I'm going to apply, and I suppose it will even sound about the same. Right, okay, so to do a hard knee, and I'm going to keep using this compressor because of its visualization, which is a lot better than Recomp. And I want to have some sort of visualization that looks like this as well. In any case, so if the current RMS, there is another difference. I think that this line here, I think that this line here may be the peak gain. No, I think that this line here is the RMS. So yeah, what we want to do is, if this line is below the threshold, we don't change anything. So the gain reduction is going to be 0. So let's see. If my sample RMS is below our threshold, then my gain reduction is going to be 0. Otherwise, we have a ratio here that I want it to be 20. So otherwise, I want the gain reduction to be, how do I even want to think about this value? I can think of the gain reduction as the multiplier. So in the end of the day, I'm going to do something like this right? Yeah, so I'm gonna say that there is no gain reduction. So I multiply the value by 1. Otherwise, I want to have just a straight knee. I'm not even going to say that it's a ratio of 20. I'm just going to say that it is a ratio of infinity. So to do that, I have to multiply this sample by a number that is going to be less than 1 and a number that is going to bring this down to the target, which is RMS. So right now, the situation is that my RMS is bigger and my threshold is smaller, and I want this number to be less than 1. So I think I need to divide the threshold by the sample RMS. I am not sure. I have to really think about this. So the threshold is in amplitude and the sample RMS is in amplitude. So that much is correct. At least that much is correct. And if my sample RMS is less than the threshold, then I'm going to multiply by 1, preserving whatever was there. Otherwise, I want this to be a straight line. So for this to be a straight line, I need to multiply the sample by a number that is the threshold divided by the current RMS. Is that right? I'm not even sure, but I think it's relatively easy to try this out. So how about we have another drawing of the gain reduction? Yes, let's have another drawing of the gain reduction. So I will have a gain reductions that is going to be a circular buffer of 2 seconds. And by the way, how is the CPU on my compressor so far? Great. I mean, it's not doing anything, but it's not over the top like we had performance issues back when I was doing the EQ. Right. Okay, so what do I have to do? My gain reductions thing, I need to push into that. So let's do something similar to this. And then finally, I am going to display the gain reduction in blue. Yeah, let's check this out, see if it even makes any sense. All right, so the gain reduction being multiplied by... Oh, no, that makes absolute sense, because the number 1 in this view here, the number 1 is the top and the number -1 is the bottom. It started as an oscilloscope kind of thing, so this makes sense. The way that the RMS goes up and then the gain reduction comes down, which means we are going to compress this guy. Yeah, I think that this makes sense. Bo says, this is not how I make my compressors, so it's great to watch and learn. This is maybe not how you're supposed to do a compressor, but it is what we are doing, so I don't know. I'm learning about compressors by doing this. Let me commit what I have, and then I want to check. So what I want to check is that we are reducing the output, and we're not. It seems like we're not affecting the gain on the output at all. So something is off. Maybe we are never reaching this value? No, we are, because of the blue line. So the blue line is already doing what it's supposed to. It's coming down. So we were supposed to be lower here in level. It was supposed to be at this -36, and it was supposed to keep there. Maybe the compressor is just too slow to react to my voice, because we have a very wide RMS window, so maybe it is reducing some of the gain and I just cannot see it. And there is also these two compressors along the chain, which cannot help me visualize my own thing, right? Right, okay, so let's try this some other way. Let's stop my voice and let's have some tone. Oh, it is reducing. Right, awesome. Let's see this in action. So if I don't have anything, my red line is over here and my blue line is over there. And then I'm gonna go up to minus 36 without any gain reduction, so no blue peaking down. RMS is up, but that's all right. The gain in and out, all the same. Then let's go up to minus 37. Still all right. Okay, Bo says something that I think is interesting. Yeah, and like you pointed out earlier, there is a bunch of compressors made the regular way. I decided to try a different approach. Fair. By the way, the lines are barely visible on the stream. If you can make thicker ones, it would be great. I was thinking about this as well, not only because of the stream, but because I can barely see it and it's in front of me. So I think that the issue is that there is no way that I know of to make a line thicker in JS Effects. Let's see. JS Effects, graphics, line. So you can only draw lines, you draw lines, but there is no way to specify the thickness of this line. I think that the only way to do this is to draw a bunch of lines and just draw them 1 pixel apart. Yeah, that shouldn't be too hard to do, right? But I can barely see the lines myself, so the problem is not the stream, okay? The problem really is the way that we are drawing the lines. So maybe we can do this by coming here to this lines graph situation. And how about... yeah, let's change this so that the... oh, snap, an issue request at the REAPER forums. Right. But we will need thicker lines, and thicker lines exist, okay? Let's go to my reference for good-looking JS effects. You can see that this line is thicker, okay? And you can do things like this, and it follows along. But I haven't checked the code, but I bet that the way that they are doing it here is that they are drawing 2 or 3 lines 1 pixel apart. So let's see if this approach even works. We can try it out. It shouldn't be too hard. Well, let's think about the way that we are drawing this. We are using this position, and the line 2 thing is going to update this position. So we need to change approaches. We need something like line X and line Y. And then instead of using this, we look at line X. And instead of that, we look at line Y. And then instead of using line 2, let's use, where is it? Come on, yeah, there you go. Let's use line instead. So it's going to go from line X, line Y, to this position. And I will have to compute on this position. So I'm going to store it. The line X next is going to be this. And I need this to be a variable, local variable as well. So let me declare it here. I don't like how I have to declare all my local variables, so used to just defining them in place. Right, but whatever. Let's do this next and next. And if you forget about it, if you forget to declare it here, it becomes a global variable, which in our case, I don't think it will make any difference because there is only one place where this is called at a time. So if these variables were global, it would be fine. But then if we had another function that used the same variables, it could be kind of annoying and it could lead to bugs. Yeah, annoying, but it is what it is. So let's get this line y next. And then, of course, we'll have to update all of these guys. So let's make a copy of these lines and do something like this. So we update for the next time around. Okay, so the whole reason why I wanted to refactor this was so that I could draw a line that was thicker. So all I gotta do is just come to these positions and go one below. Let's see if this makes things thicker. Full compile reset. Yes, the line is thicker now. Great. Let's go with 3 pixels. Or you know what? Let's parameterize this. Thickness. And then my thickness so the thickness is going to be like 1 or 2 or 3. So what I'm going to do is I will have something like thickness index, whatever. And then I'll say that the thickness index starts at minus... what am I doing? I don't even need all of this. This index thing I don't need. No, I do. I do need. Yeah, let's do this. It's equal to -1. Then we are going to do a loop that is going to run for thickness times. And we are going to update that index by 1 each time around. Good old loop. And on this loop, we are going to do something that looks like this. And then when I save this, of course, I broke everywhere where this function is used, but never mind that. That's easy to fix. All we gotta do is find all those cases and pass a thickness. So I think that my oscilloscope, my samples, I actually want to draw... Let me put some new lines here. I actually want to draw this with a thickness of 1, and then the other 2 I can draw with a thickness of 3. And then in the demonstration effect, I also think I have some instances that I need to update. Just 1, but let's go there and display this with thickness of 1, just so we don't leave things broken. Now let's refresh this. All right, so I now have a thickness of 3. The CPU is still all right. It seems like we are doing this. Bo, is this good enough for you to see on the stream? The blue is stuck here at the top, so that's probably not ideal. But the red, oh, so maybe now it's time for us to give some padding to the thing, right? But is the thickness all right? Do you want me to make it thicker? It shouldn't be too hard now. It's just a number, I can change it. I'll make it like this. And on my height, well, on my x-axis, I'm not going to change anything. So it's still going to touch the left and right. But I'm going to give 10 pixels worth of padding on top and bottom. GFX X Retina. Great. Oh no. So Bo says that it looks fine now. That's great. And then I'm going to go give it padding on top and bottom, just like that. Now we can see the blue line, but the white line became red. So I passed the wrong numbers here. Let me move this out of the way. I still want to see the chat on the second screen. There you go. Let's try this again. And there we have it. I feel like the interface is a bit more sluggish now that I'm drawing more. So maybe drawing lines is not ideal. Maybe I should draw little rectangles. I don't want to dive into that right now. So I'll just leave it at that. It's not as smooth as it was before with a single line. Whatever. Probably I should have a special case. So if the thickness is 1, I don't do a loop because looping is supposed to be expensive. Whatever. I'm not worrying about performance. I'm worrying about gain reduction. So I'm at minus 37. I shouldn't see any gain reduction. At minus 36, this blue line should still be untouched. Shouldn't see any difference. Oh, now that it's not stuck at the top, I cannot see if the change is very small. I won't see it going down. So I think there is an objective reason for this to be stuck at the top, though it's not perfect and it will change, but now it should be stuck at the top again. Right, okay. So let's go to minus 35 and we should see some gain reduction. Now, I can barely see the gain reduction, but I think it changed. Let's go to something more drastic. Yes, the gain reduction is happening. I can see that the value coming in and the value going out are not the same value. Now, what could be fun is if we did the following. First, let's commit what we have. Then we are going to store some samples. I'm going to say that I'm going to store the samples. All right, those are all the places .in. And I will also have the samples going out. And then the sample out is going to be that. And I will push. So maybe I'm going to make it so that I am going to compute everything. Then I'm going to assign everything. Just like that. And I have 2 of the gain reductions because one of them... Oh, so this needs to be here, I suppose. Not quite, actually. It could be below. There you go. Did I introduce any bug in the process? I don't think so. So the sample coming in is just SPL0, and then RMSs is the sample RMS. That's this guy there. Then we have the gain reductions. Then let's have the samples out. We just push the sample out. And then when we display this, we are going to display the sample coming in gray, the sample going out in white, the RMSs and the gain reductions, all of that. There you go. And now you can actually see compression happening. Now the interface, it feels very sluggish to me. I don't know if the stream translates that, but it feels sluggish to me just by looking at it. But the CPU is not an issue. But this is only showing the CPU for the audio processing as far as I can tell. It's not showing me the CPU used to do the drawing. And I'm not sure if it's optimized using some GPU or if it's all done in the CPU. And maybe it's even affecting the quality of the stream. Who knows? These things are weird. But you can see the gain reduction happening in real time. In fact, let's turn off this tone generator and turn it on my voice again. And now you can see the compression happening. That is a freaking big deal to me. It kind of works. I am amazed by this. In fact, I'm going to commit this. And I am going to wrap this up. that's it, guys. Thank you very much for being here. Tomorrow, I will not be over at IDDQD. Tomorrow, I will be here working more on something. I'm not sure exactly what. I may continue doing this library, this compressor. In fact, let me decide what I'm going to do. I'm not going to work on the compressor, I don't think. So let's decide together. In this compressor here was a bit of fun, but maybe let's get back to the design system. I mean, I think that doing that will be just like kind of repetition, but it needs to be done. Abo wants to see some more coding. Yeah, so maybe we will continue the compressor. Maybe we'll do something here on this list. You know what? Something that could be cool to do is this. We could get into FFTs. Yeah, that is a lot of coding, Bo. You will not be disappointed. So right now, this is like a big experiment, and every day I'm doing something fun and different. I'm having a lot of fun doing this, but someday we'll have to get down to business and actually do like effects with this thing. But maybe, yeah, let's do some DFTs tomorrow and see how that comes out. It will be a challenge. I have never done that either. But yeah, it will be a fun challenge. So yes, that's what we are doing tomorrow. I see you back here tomorrow. Thank you all very much for being here, for supporting me, for going to PayPal and Patreon and sending me money, or for just being here on the chat. See you back here, not at UDQD, back here tomorrow. Let's do some Fourier transforms. Have a good one. Bye.